So good day, grade 8 Nahati Science High School students. For our second module for the fourth quarter, we're going to be discussing about inscribed angles. Okay, and this is going to be our second lesson for this module. Okay, so let's start with our first problem. Mihan created her own ant terrarium for their school's biology fair. To finish her project, she created a draft of her ant terrarium as shown below, with the ant stronghold as the quadrilateral. From the top view of the terrarium given below, we need to find the measurement of angle X, angle Y, and then also the measurement of RQR. So how are we going to solve for these three values? We have to first remember the theorem about a quadrilateral, a theorem about circles inscribed in a circle. Okay, so there's a quadrilateral inscribed in the circle. So there's a theorem about that. So according to that theorem, if a quadrilateral, okay, is inscribed in a circle, then the opposite angles, okay, so the opposite angles are supplementary to each other. So therefore, we can say, based from this figure, that the measurement of angle Q plus the measurement of angle S is equal to 180 degrees, and the measurement of angle R plus the measurement of angle P is 180 degrees as well. And this should give us a quadrilateral. Okay, so the first value that we can solve for this problem is the value of x. So how can we do that? We can use our second equation here. Okay, so for this one, we can use, since the measurement of angle R is equal to x, we can write here x plus the measurement of angle P, which is equal to 80. So that's going to give us 180. And if we transfer or transpose 80 to the other side, so this is going to be 180 minus 80. And therefore, x is just equal to 100 degrees. Okay, so for this problem, x is equal to 100 degrees. Okay, so how can we solve for the measurement of angle y? That's the second problem. We need to solve for the measurement of angle y. We also have a theorem about inscribed angles. So an inscribed angle, okay, so an inscribed angle here, so that's 75 degrees. That is that's one half of this inscribed angle here. That's one half of this intercepted arc. Okay, so our intercepted arc for this given figure is going to be PQR. So let's continue with our problem. We can also say that this 75-degree angle here, that's one half of this this intercepted arc, based from the inscribed angle theorems that we have. Okay, so for therefore this inscribed angle here, so that's the measurement of angle S. So number 2, to get the measurement of this angle of this intercepted arc QR, okay, to get the measurement of Y, since we already found X, to get the measurement of Y, so that's gonna be one half, okay, one half of the measurement of angle of arc PQR. It should be equal to the measurement of angle S from the inscribed angle theorem formulas. So we solved for X here, and now we're gonna solve for Y. So carrying out this formula over here, we can say that one half the measurement of PQR, so that's just gonna be 70 plus Y, so that should give us 75. Okay, so for this one, we can multiply both sides by 2, okay, to cancel the one half over here. So that should give us 70 plus Y is going to be equal to, so what 75 times 2, so that's equal to 150, okay? And therefore, Y is going to be equal to 150 minus 70. And what's 150 minus 70? So that should give us 80 degrees. So therefore, Y is just equal to 80 degrees for this one. So the value here is equal to 80 degrees. The value here is equal to 100, this one, 100 degrees, okay, X. And now we have to solve for the measurement of arc PQR. Since the measurement of arc PQR is equal to 70 plus Y, and we know that the value of Y is equal to 80, so that's going to be 70 plus 80. And with 70 plus 80, that should give us 150 degrees back again. So there you go. So therefore, the measurement of arc PQR, okay, so it's just equal to 150 degrees for that one. And that's how we solve this problem.